Invest 90L has rapidly become one of the most closely monitored weather systems in the Atlantic Basin, as meteorologists continue tracking its development over warm ocean waters. What began as a broad area of disturbed weather has gradually organized into a more structured system, showing increasing signs that environmental conditions may support further strengthening. Forecasters are paying close attention because the system has demonstrated persistence, improved organization, and growing thunderstorm activity, all of which are important indicators when assessing the potential for tropical cyclone formation. As satellite imagery continues to reveal changes in the storm structure, experts are working around the clock to determine how strong the system may become and what impacts it could eventually bring. The designation INVEST is used by meteorological agencies to identify weather disturbances that require closer observation. When a system receives an INVEST designation, it means forecasters believe it has enough potential development to justify additional analysis and computer model tracking. INVEST 90L entered this stage after showing signs of increasing organization within a region of favorable atmospheric conditions. Since then, weather experts have been examining satellite data, ocean temperatures, wind patterns, and environmental factors to understand how the disturbance is evolving and whether it may transition into a tropical depression or tropical storm. One of the primary reasons INVEST 90L has attracted attention is the gradual improvement in its thunderstorm activity. Tropical systems rely on clusters of thunderstorms to organize around a developing center of circulation. Over recent observations, meteorologists have noted that thunderstorms associated with INVEST 90L have become more concentrated and persistent. This increase in organized convection is often viewed as a positive sign for tropical development because it suggests the system is becoming more efficient at generating and maintaining energy. Warm ocean temperatures are playing an important role in the system's strengthening process. Tropical weather systems derive their energy from warm water, which provides the heat and moisture necessary to fuel thunderstorm development. The waters beneath INVEST 90L are sufficiently warm to support continued growth, allowing rising air to transport energy upward into the atmosphere. As this process continues, the system may become better organized and potentially strengthen further. Ocean heat content is particularly important because it determines how much energy is available to sustain development over time. Another factor contributing to the system's potential is the presence of relatively favorable atmospheric conditions. Strong upper-level winds can disrupt tropical systems by displacing thunderstorms away from the center of circulation. This phenomenon, known as wind shear, often prevents disturbances from organizing into stronger storms. In the case of INVEST 90L, current analyses suggest that wind shear has remained manageable in the region, giving the disturbance an opportunity to gradually improve its structure. If these favorable conditions persist, the system may continue strengthening over the coming days. Satellite imagery has become one of the most valuable tools for monitoring INVEST 90L. Modern weather satellites provide detailed observations of cloud patterns, thunderstorm intensity, moisture distribution, and circulation characteristics. Meteorologists carefully analyze these images to identify signs of development. Recent satellite observations have revealed increasing curvature within the cloud structure, suggesting that the system may be developing a more defined circulation. Such features often indicate that a disturbance is progressing toward becoming a tropical cyclone. Computer forecast models have also become a central component of the monitoring process. These sophisticated systems analyze vast amounts of atmospheric and oceanic data to simulate possible future scenarios. Multiple forecast models are currently tracking INVEST 90L. And while differences exist among their projections, many indicate the possibility of continued strengthening. Forecasters examine model guidance carefully, comparing trends across multiple simulations rather than relying on any single forecast. This approach helps provide a more comprehensive understanding of potential outcomes. One challenge associated with forecasting developing tropical systems is the inherent uncertainty involved. Small changes in environmental conditions can significantly affect how a disturbance evolves. Variations in wind patterns, moisture levels, and ocean temperatures can alter both intensity and track forecasts. As a result, meteorologists emphasize that early predictions should be viewed as possibilities rather than certainties. Continuous monitoring is essential because conditions can change rapidly, especially during the early stages of development. As INVEST 90L strengthens, questions naturally arise regarding its future path. Determining the track of a developing tropical system involves analyzing large-scale steering currents within the atmosphere. High-pressure systems, low-pressure areas, and other atmospheric features influence where storms travel. At this stage, forecast guidance suggests several possible scenarios, though confidence remains limited due to the system's developing nature. Forecasters continue evaluating new data as it becomes available, refining projections, and updating forecasts accordingly. The possibility of tropical cyclone formation has increased interest among coastal communities and emergency management agencies. While it remains too early to determine specific impacts, preparedness officials closely monitor systems like Invest 90L because early awareness allows more time for planning and response. Even relatively weak tropical systems can produce heavy rainfall, strong winds, rough surf, and localized flooding. Understanding potential risks in advance is an important component of effective preparedness. Meteorologists also pay close attention to the storm's internal structure when assessing development potential. Tropical cyclones become stronger when they establish a well-defined circulation and maintain concentrated thunderstorm activity near the center. Observations of Invest 90L suggest gradual improvements in organization, though additional development will be necessary before the system can be classified as a tropical depression. Aircraft reconnaissance missions may eventually be deployed if the disturbance continues strengthening, providing direct measurements of wind speeds, pressure, and structural characteristics. Moisture availability represents another favorable factor supporting the system. Dry air can weaken developing storms by disrupting thunderstorm activity and limiting convective growth. Current analyses indicate that Invest 90L is embedded within a relatively moist environment, reducing the likelihood of significant dry air intrusion. This moisture-rich setting supports sustained thunderstorm development and enhances the system's ability to organize over time. The Atlantic hurricane season often produces numerous disturbances, but only a portion of them develop into named storms. What distinguishes Invest 90L is the combination of favorable environmental conditions and increasing structural organization. Forecasters have observed trends suggesting that the system is gradually becoming more efficient, which increases the probability of further development. However, they also recognize that tropical weather systems can be unpredictable, particularly during formative stages. Meteorologists also pay close attention to the storm's internal structure when assessing development potential. Tropical cyclones become stronger when they establish a well-defined circulation and maintain concentrated thunderstorm activity near the center. Observations of Invest 90L suggest gradual improvements in organization, though additional development will be necessary before the system can be classified as a tropical depression. Aircraft reconnaissance missions may eventually be deployed if the disturbance continues strengthening, providing direct measurements of wind speeds, pressure, and structural characteristics. Moisture availability represents another favorable factor supporting the system. Dry air can weaken developing storms by disrupting thunderstorm activity and limiting convective growth. Current analyses indicate that Invest 90L is embedded within a relatively moist environment, reducing the likelihood of significant dry air intrusion. This moisture-rich setting supports sustained thunderstorm development and enhances the system's ability to organize over time. The Atlantic hurricane season often produces numerous disturbances, but only a portion of them develop into named storms. What distinguishes Invest 90L is the combination of favorable environmental conditions and increasing structural organization. Forecasters have observed trends suggesting that the system is gradually becoming more efficient, which increases the probability of further development. However, they also recognize that tropical weather systems can be unpredictable, particularly during formative stages. Public interest in Invest 90L has grown as weather enthusiasts, coastal residents, and media outlets track its progress. Advances in technology have made real-time weather information more accessible than ever before. Satellite imagery, forecast discussions, and model projections are readily available to the public, allowing people to follow developments closely. While this access provides valuable information, meteorologists encourage individuals to rely on official forecasts and avoid drawing conclusions based solely on individual model runs or speculative interpretations. Should Invest 90L continue strengthening, it may eventually receive an official tropical cyclone classification. Tropical depressions form when a system develops a closed circulation accompanied by sustained winds below tropical storm strength. If winds increase further and meet established thresholds, the system would be assigned a name and classified as a tropical storm. The transition from disturbance to tropical cyclone marks an important milestone in a storm's evolution and typically leads to increased monitoring and public awareness efforts. Oceanic and atmospheric conditions across the region remain generally supportive of development in the near term. Warm waters, sufficient moisture, and manageable wind shear create an environment conducive to strengthening. Forecasters are carefully evaluating whether these conditions will persist long enough to allow significant intensification. Changes in any of these factors could influence the storm's future, highlighting the importance of continuous observation and analysis. As Invest 90L continues to evolve, meteorologists remain focused on identifying key trends that may signal future changes in intensity and organization. Every new satellite image, weather model update, and environmental analysis contributes to a more complete understanding of the system. While uncertainty remains regarding its ultimate strength and track, the evidence currently suggests that Invest 90L is becoming increasingly organized and warrants close attention. The coming days will likely provide greater clarity regarding the system's future. Additional observations will help determine whether the disturbance can maintain its current strengthening trend and transition into a tropical cyclone. Until then, meteorologists will continue monitoring every aspect of its development, analyzing environmental conditions and refining forecasts as new data becomes available. Invest 90L's progression serves as a reminder of the dynamic nature of tropical weather systems and the importance of staying informed during hurricane season. With favorable conditions surrounding the disturbance and signs of increasing organization becoming more apparent, the system remains one of the most closely watched features in the Atlantic, as forecasters assess its potential to become a significant storm. As Invest 90L continued moving across the Atlantic, meteorologists became increasingly interested in the system's internal structure and how rapidly it was evolving. While many tropical disturbances struggle to maintain organized thunderstorm activity for extended periods, Invest 90L demonstrated notable persistence. Satellite imagery revealed repeated bursts of convection developing near the center of circulation, suggesting that the system was successfully drawing energy from the warm ocean below. These persistent thunderstorm clusters are often among the earliest signs that a disturbance may be transitioning into a more organized tropical cyclone. Forecasters carefully monitored these developments because they provided important clues regarding the storm's future intensity potential. One of the most critical aspects of tropical cyclone development is the formation of a well-defined low-pressure center. During the early stages of development, many disturbances contain multiple areas of circulation competing for dominance. This lack of organization can prevent a system from strengthening efficiently. In the case of Invest 90L, meteorologists observed gradual consolidation of energy toward a common center. Although the circulation remained somewhat elongated at times, there were increasing indications that the system was becoming more organized. This trend raised confidence among forecasters that further development remained likely if environmental conditions continued to cooperate. Atmospheric moisture remained one of the key factors supporting Invest 90L's growth. Tropical systems require a deep layer of moisture throughout the atmosphere to sustain strong thunderstorm activity. Dry air can infiltrate developing storms and disrupt convection, often weakening or delaying organization. Fortunately for Invest 90L, analyses indicated that the surrounding environment contained relatively high moisture levels. This favorable setting allowed thunderstorms to persist and regenerate, helping the system maintain its overall structure. The presence of abundant moisture also reduced the likelihood of significant weakening from dry air intrusion in the short term. Sea surface temperatures across the storm's projected path remained sufficiently warm to support continued intensification. Warm water acts as fuel for tropical systems by providing heat, energy, and moisture that drive convection. Meteorologists often pay close attention not only to surface temperatures, but also to ocean heat content beneath the surface. Regions with deeper layers of warm water can support stronger storms because they reduce the cooling effects caused by the storm's own circulation. Current observations suggested that Invest 90L was moving through an environment where oceanic conditions could continue supporting development. Forecast models began showing greater agreement regarding the likelihood of tropical cyclone formation. While differences remained concerning exact timing and intensity, many simulations projected gradual strengthening over the following days. Model consensus is often an important indicator because it reflects agreement among multiple forecasting systems using different methodologies. Although no forecast is ever certain, increased model agreement typically leads to higher confidence in general development trends. In the case of Invest 90L, the growing consistency among forecasts suggested that the disturbance was becoming a more serious candidate for tropical cyclone classification. Meteorologists also examined upper-level atmospheric conditions to determine whether the system would encounter obstacles to development. Wind shear remained one of the primary concerns. Even relatively weak tropical systems can struggle when exposed to strong upper-level winds that tilt or displace their circulation. Fortunately, current analyses indicated that wind shear remained relatively low to moderate in the vicinity of Invest 90L. This favorable environment allowed thunderstorms to remain concentrated near the center, increasing the likelihood of further organization. However, forecasters continued monitoring potential changes because increases in shear could quickly alter the storm's development trajectory. The possibility of rapid intensification also became a topic of discussion among weather experts. Rapid intensification occurs when a tropical cyclone experiences a significant increase in wind speed over a relatively short period. While not all storms undergo rapid intensification, favorable combinations of warm water, low wind shear, and strong internal organization can create conditions that support accelerated strengthening. At this stage, forecasters emphasized that it was too early to determine whether Invest 90L would experience such a process. Nevertheless, the environmental setup warranted close observation because conditions appeared supportive of at least gradual strengthening. As public awareness increased, emergency management officials began emphasizing preparedness rather than prediction. Tropical weather systems can evolve quickly, and forecast details often change as new data becomes available. Officials encouraged residents in potentially affected regions to review emergency plans, monitor official forecasts, and ensure access to reliable sources of information. Preparedness efforts are most effective when initiated before a storm becomes an immediate threat, allowing individuals and communities sufficient time to take appropriate actions if necessary. Aircraft reconnaissance missions were also being considered as a potential tool for monitoring Invest 90L. While satellite imagery provides valuable information, direct observations collected by specialized aircraft offer a more detailed picture of storm structure and intensity. Reconnaissance flights can measure wind speeds, atmospheric pressure, temperature, humidity, and other critical parameters. If the disturbance continued strengthening, aircraft data would help forecasters determine whether a closed circulation had developed and whether the system met criteria for tropical cyclone classification. One of the reasons Invest 90L attracted considerable attention was the timing of its development within the broader hurricane season. Seasonal atmospheric patterns can influence how favorable conditions are for storm formation and intensification. Certain periods are known for increased tropical activity due to warmer ocean temperatures and supportive atmospheric environments. Invest 90L appeared during a time when several environmental indicators favored development, contributing to the heightened interest among meteorologists and weather enthusiasts. Another important consideration involved the potential impacts associated with heavy rainfall. Even systems that remain relatively weak in terms of wind speed can produce significant precipitation. Slow-moving tropical disturbances are particularly capable of generating prolonged rainfall that may lead to flooding. Forecasters therefore evaluated not only the system's wind intensity potential, but also its rainfall-producing capabilities. Communities within potential impact zones were advised to remain aware of flood risks, especially in areas already vulnerable to heavy precipitation. Coastal conditions also became a focus of concern. As tropical systems strengthen, they can generate large ocean swells that travel far beyond the storm's immediate vicinity. These swells may create dangerous surf conditions, rip currents, and coastal erosion. In some cases, such impacts occur even when a storm remains hundreds of miles offshore. Marine interests, beachgoers, and coastal communities were encouraged to monitor forecasts closely as Invest 90L continued developing over open waters. Forecast uncertainty remained a recurring theme in meteorological discussions. Although confidence increased regarding the likelihood of development, questions remained concerning the storm's ultimate intensity and track. Tropical systems are influenced by a wide range of atmospheric factors, many of which can change over time. Small variations in steering currents or environmental conditions may result in significant differences in future forecasts. As a result, meteorologists emphasize the importance of focusing on forecast trends rather than any single model projection. Technological advancements played a major role in monitoring Invest 90L. Modern satellites provide near-continuous observations of cloud structure, temperature patterns, and moisture distribution. Advanced computer models process enormous amounts of atmospheric data to generate increasingly sophisticated forecasts. These tools have dramatically improved forecasting capabilities compared to previous decades. However, despite these advancements, tropical weather remains inherently complex, and uncertainty continues to be an unavoidable aspect of forecasting. The broader scientific significance of storms like Invest 90L extends beyond immediate forecasting concerns. Each developing system provides researchers with valuable opportunities to study tropical cyclone formation and intensification processes. Data collected during these events contribute to improvements in forecasting models and scientific understanding. By analyzing how disturbances evolve under different environmental conditions, meteorologists refine techniques used to predict future storms more accurately. As the system continued strengthening, forecasters watched for signs of core development. Strong tropical cyclones typically possess a concentrated central region where thunderstorms wrap around the center of circulation. The establishment of such a core often marks a transition toward greater organization and efficiency. Satellite imagery suggested that Invest 90L was gradually progressing in this direction, though additional development remained necessary before definitive conclusions could be drawn. Public interest continued growing as weather updates highlighted the system's increasing organization. News outlets, meteorological websites, and social media platforms shared frequent updates regarding forecast changes and development probabilities. While increased awareness can be beneficial, experts encouraged the public to rely on official meteorological sources rather than unverified information. Accurate communication is especially important during tropical weather events because misinformation can lead to confusion and unnecessary concern. Looking ahead, the future of Invest 90L depended largely on whether favorable environmental conditions would persist. Warm ocean temperatures, abundant moisture, and manageable wind shear created an environment conducive to strengthening, But tropical systems can encounter unexpected obstacles. Changes in atmospheric patterns, interactions with dry air, or fluctuations in oceanic conditions could influence development. Forecasters therefore remained cautious while acknowledging the growing potential for further intensification. The continued strengthening of Invest 90L served as a reminder of how quickly tropical weather systems can evolve. What began as a broad area of disturbed weather had gradually transformed into a more organized and closely monitored system. Each new observation added to the understanding of its structure and future potential. While uncertainties remained regarding exact impacts and ultimate intensity, the evidence suggested that Invest 90L had become a significant feature within the Atlantic Basin. Meteorologists would continue tracking every aspect of its development, providing updates as conditions evolved and new information became available. For now, the storm remained under close observation as experts worked to determine whether it would become the next named tropical cyclone of the season and what challenges it might present in the days ahead.